Welcome. We are going to start Terraform from today. Terraform is actually owned by HashiCorp, so it's called HashiCorp. Terraform is actually an infrastructure as a code tool that is extensively used in the wider IT landscape, and many people actually rely on Terraform for provisioning their infrastructure. When I say provisioning the infrastructure, it goes down from the VPC to the subnets to all the networking that we did in the earlier part. The servers, the load balancers, the network load balancers, the Route 53s, the RDS databases, everything and anything which is available in AWS can be created via Terraform as well. Terraform is just a wrapper, right? So it actually deals with the Amazon APIs, AWS APIs to create the resources. So it's an infrastructure as a code. What is infrastructure as a code in the first place? It is a way of defining and managing your infrastructure using code. So just like application code that sits right, the HTML files, the CSS, the JavaScript, AngularJS, PHP, whatever language the application has been written in, right? Like the application code, something similar we have for an infrastructure code. So rather than the manual process like clicking through the user interface or using the command line like we did yesterday, in the previous class, we did AWS S3 related commands. So those kind of stuff can also be done. So instead of doing or running all of these multiple commands to create the resources, you could have something called as a code base, which is organized in the form of folders and files inside it, which will help you create the sources. This means that you can manage your infrastructure in the same way that you manage your application code with version control, automation, collaboration. Other words, infrastructure as code is a way of making your infrastructure more like a software. Historically, right, infrastructure as code has seen many iterations, starting with configuration management tools like CF Engine, Chef, Puppet, Ansible, and Salt. So Ansible, which we will be discussing in the later part, will also be having also has AWS related modules which can be used to actually create resources. But we'll not be using Ansible because that is best for configuration management and not for infrastructure provisioning. What is configuration management? Let's say there is a server and you want to install HTTPD, the Apache web server, and then you want to place a HTML file inside the root, inside the var.html directory, right? For those kind of scenarios, Ansible would be better. Ansible is not best for creating infrastructure, right? Newer tools like CloudFormation and Terraform take a declarative approach and focus on the actual provisioning of the resources as opposed to the configuration of existing ones. The newest generation of tools focus on using the capabilities of existing imperative programming languages that are underlying the binary files. Now, CloudFormation and Terraform is what we can use. CloudFormation on one hand is only and only for AWS, right? So CloudFormation is an AWS service that gives you again an infrastructure as a code kind of feel, wherein you can write a certain code. Could be a description in a YAML file of what are the resources, what the type of resources and stuff like that. And if you run it, it will create that resource for you. So if you give a VPC code for CloudFormation, it's going to create the VPC for you, right? So that is CloudFormation. The only challenge is if you use CloudFormation, right? In future, if you want to migrate from AWS to Azure, or let's say you want to have a multi-cloud architecture wherein you also want to use Azure and GCP, in that case, it would be very, very, very difficult because CloudFormation is only and only agnostic to AWS. For Azure and GCP, you would have to think about something else. But if you learn either Terraform Terraform can be used across all the cloud providers and many more. Right. So Terraform is a tool for provisioning, managing, and deploying infrastructure resources. One, it is open source, written in Golang and created by HashiCorp, which is the company which owns it. Can manage infrastructure of your applications across multiple cloud providers like AWS, Azure, GCP, Alibaba, and many more. Right. So you have a lot of providers. So in Terraform terms, all of these cloud providers are actually called as providers in Terraform. So in Terraform, you have something called as a provider, which is going to provide you the uh, capabilities of creating the infrastructure. So you have GCP, Google Cloud Platform, Azure, Alibaba Cloud, Oracle Cloud Infrastructure, Kubernetes, AWS, you name it and you have it, right? It's not just these providers that are there. There are also many other providers that are out there. I will quickly give you a walkthrough of the providers. So Terraform providers. If you see, this is the major ones that are there in the bold, and then you have many other, right? So you have many providers that are available, which can be done. So if you see, there are 103 pages out of it which you can use. So some of them are official, some of them have been created by other people, uh, which if you want you can rely on. If you don't want, you can give it a skip. But there are multiple providers that are out there. Okay, so all of this is something which can be utilized to write and run our code. Now we will be focusing on the most used provider, that is AWS, and also this is a continuation of the entire course. Now we have already discussed the entire AWS part, so we will be discussing about how we can leverage Terraform to create those AWS services. Coming back, this is a list of providers. Now, what are the key features that we have in Terraform? Um, there are many steps generally which have to be followed when dealing with a tool or a new language, right? So the obvious one is, number one, you need to write some Terraform configuration, right? And that has to be saved in a certain file with a certain extension. We'll be discussing what those extensions and what those files are. So you will be writing some Terraform code. Then you would be initializing the directory. Now, directory is nothing but the folder in which you have written the code. So you would be initializing that directory so that Terraform can start to make action, right? What Terraform init does is it will download the plugins into that directory. I'll actually show you what those plugins are, what those files are. It is actually going to download that plugin for you. That plugin is actually, or the files which are downloaded after that, right? The plugin is actually going to create the resources for you, right? In order to create a resource, you need to do a Terraform apply. If you want to see what resources are to be created, you can do a Terraform plan. A Terraform plan is going to give you an exact detail of the plan of execution or what resources Terraform wants to create on behalf of it. Now, if you're okay with the plan, you could do an apply, which I'll actually show you in detail. Right, we will be doing this in detail, so nothing to worry about that. Now, what are the extension files that we would be dealing with? There are many extensions apart from these, but this is the basic extensions that we will be doing. So the first is a .tf, that is a Terraform file. The other is a .tf vars, which is used to save variables. We'll be looking at variables probably in the third class from now. Then we have something called as tf state file. I'll be discussing what a state file is in detail in the coming slides. And these would be the basic ones. Out of these two, .tf state is something which Terraform creates for you. So you don't have to do anything with that. A .tf file and .tf vars file is written by you. right? You would have to write it out. What is a state file? So this is the most important reason why people choose Terraform. That is the state file, right? So what Terraform does is it keeps a track of the state of the resources it has created for you. Let's say you write in a code for Terraform to say that create a VPC for me. So you do a Terraform plan, so it will give you a plan. Then you say, okay, I like the plan, do a Terraform apply. So when you do a Terraform apply, then also it's going to give you a plan. You have to say yes, and then Terraform will create that thing for you. Now, what Terraform is going to do is it is going to remember all the details of that VPC that it has created for you, like the VPC ID, the VPC CIDR, all the settings in the VPC, everything and anything that you feel or you see on the AWS console for that VPC, that information would be saved in the state file. Now, the state file is more of a JSON format. You can either have it locally or you could have it in some remote location. We'll discuss what the remote location is afterwards, but that state file is somewhat created in your working tree. Now, the next time you make some changes, let's say you decide, no, I don't want the CIDR to be 10.18.0.0/16, but I want it to be 10.20. Something dot something dot something. Then you just have to make your changes in the configuration file. Terraform is going to first check in the local state file and check on your code. Are the configurations matching? It will see that the configuration is not matching, and then it would initiate a change. Right. So that is when it will give you a plan that yeah, the actual configuration and this is way apart. I want to make it a change, and you can then make a change of the configuration. Right? That is how it works. We'll actually look at this practically, but this is what a state file is. And this is the only reason why people love Terraform, because it keeps a state file, right? So if something changed, you can actually go to the different versions of the state file and see what had actually changed or why something is not working, right? So that is something that can be done, and then it's very, very easy to replicate it back or revert it back, right? So that's about the state file. A remote state file. This section is of remote state file. We'll be discussing about that in the later section of the course. So this is where we are, and so this is how you need to start working with AWS providers. But in the meantime, what we can definitely do is go inside this, go inside CP, go batch number 38, and we can start writing our code over here. So I'll create a file called as terraform.aws, and let's actually create this file. So this is an empty directory that I have, right? And to start using AWS, right, what you need to do is in this empty directory or in this empty folder, I am actually using VS Code as my editor. And in this empty directory, what you need to do is create a file. So what is the file? The file could be of any name, any .tf, right? It should be with an extension of .tf, which is the Terraform file. Generally, we name that as main.tf. Understood? So just created a file called as main.tf, and now I can start using my Terraform to writing the code for AWS. But before I do that, I should make sure that I have access to AWS. Yes, I have access to AWS. Now, how did I get access to AWS? So what you need to do is you need to make sure that you have a user account, that is access key and a secret key. If you're not sure how that is done, let me quickly show you. You need to go to IAM in the AWS console. Go to IAM over here. And what we need to do is go to users. Where is users? You need to go to users. Under users, you have my user. Here, there is something called as security credentials, and I already have certain set security credentials. right? I cannot create another security credentials. I guess two credentials is a limit. So let's go to the other user and try to get a user. So my user security credentials would be 0. So I can create an access key. I'll call it as command line, blah blah blah. I'll say I understand. I click on next. You can give a description if you want. And this is a access key and a secret key that you will get. You need to download this file. Once you download that file, what you need to do is AWS configure. Now let's say AWS configure gives you an error that AWS is not found. Then you need to go ahead and install AWS CLI on your laptops. AWS CLI installation. If you are on Mac, follow the Mac instructions. So there is MacBook instructions. If you're Linux, you follow the Linux instructions. I was in Windows, so I followed the Windows instructions to get my AWS installed. Right, right. Once you do this, what you need to do is AWS configure. Here it is going to ask you for the secret key, the access key, the secret key, the region in which you want to operate, and that's it. Right. So make sure that you're doing all of this so that you are able to connect to your AWS account. How do you test if you're able to connect to the AWS account or not? Just do an AWS S3 LS and you would be able to connect to your AWS account. Or maybe test at least if you have access or not. If you don't have access, you will get credentials not found. If you have access, you'll get this. Now let's say you don't want to do all of this on your local laptop. Okay, very good. How can I do it in other ways? You could maybe create an EC2 instance, install Git on it, right? Do a yum install Git. You'll get the GitHub installed on it, and then from there you could actually run your code, right? So that is another place where you can actually do your stuff. Okay, now that I have this code, right? I have this file system. What do I write inside that? How do I know what to write inside that? Right?